Hi folks, welcome back to notOnlyCode. I'm Gregory and today we are building a second part of our own unit test framework in 100 lines of Python code. If you haven't seen the part number 1, make sure to check it out. The link should be somewhere here in the corner of this video. And you can grab the source code, you can download it, and you can continue with us working on our own framework. In part number 1, we built a test runner. Currently, we can run our test framework and pass it a single test file or a directory. It will find the tests automatically, it will execute them one by one, and it will print the results and a summary, whether all the tests succeeded or whether at least one of the tests failed. In this part, we will build our own assertion library. So first, let's check what it exactly is. Assertion library is basically a set of functions that allow us to determine whether the results that we got are the expected results. It allows us to check whether two values are equal or whether they are different. They allow us to check whether an array has certain element, whether a dictionary has certain key. Python itself has a keyword called assert, which allows us to determine if some value is true, and if it's not, it will throw an exception. We use this keyword to run tests in the first part of this tutorial. However, assert is just one keyword, and there are a lot of different ways to perform the test. So here's our plan for today. First, we will wrap our module in a package so that we can add more modules there and so that we can run it as a package and not as a single Python file. Second, we will add the expectations module and we will define two different assertions there. First, we will check whether something is equal, and second, whether it's not equal. In the end of this video, I will also tell you what we will do in the last part of this mini video series. And in the meantime, grab the source code and let's build an assertion library. So what I want to do now is support this new format of test that will use the word expect and then function toEqual and later notToEqual. I created a new directory called specs and I added these two test files there. So we will be able, once we update our library, to see whether it supports this new test format. Now we'll start by turning our single module into a package so that we can put multiple modules there and so that we can call it from outside of the directory. We'll call it notTest, that will stand for not only code test. And let's see what we want to move there. We want to move the runner, we want to move the colors there. I want to have a new module called expectation here. Now I want to turn that package into runnable one so that I can just pass the name of the package and it will execute the test runner. I want it to work like this. Just that right now it doesn't work because it says notTest is a package and cannot be directly executed. Let's change that. In order to make the package runnable, we just need to add one file called main. And in that file, we need to execute the code that we want to run when someone executes the package. So first we will import our runner. And then we will just call it. Alright, so we are importing the runner package. Now our runner doesn't have this main function, but let's add it. So here, instead of running it when it's executed as a script, we will just add it as a new function. Let's see if that works. Right, we have a different error now. It says module not found colors. So we don't have the colors module. Let's see what's happening there. The colors module now belongs to our package. So we just need to import it from our current package. And that should work. Alright, now our package, our notTest package is executable, so we don't need to use the runner file directly. We don't even need to know that the runner file is there. The user doesn't care about what files belong to our package. They just know that the name of the package is notTest and they can run it like this. Let's start building our expectation library. First, we will add a module called expectation, and here we can just say in our number test, we'll say from notTest .expectation import expect. We just need a single function. Alright, so here we need to add this function. So let's say we'll just write it straight here, def expect. We will expect a certain value. So let's say value And then what we will return is we'll return a new object. Now, let's create this object first and we will return it in a moment. Okay, why we are building a new class here? Because you see our format that we want to have is expect something and then .toEqual. So expect needs to return an object that will respond to the toEqual method. So this object will be our expectation class. Now expectation will take a single value in the initializer. And it will have the toEqual function. That's it now, and now our spec number test should work, but let's see, let's print something here. Now we'll see whether all the values are passed correctly there. And now instead of running into the test directory, we'll run on specs and we'll just pass the numbers test here. Alright, I broke something, of course, I missed parentheses. Now should be fixed. Alright, we have non-type has no attribute equal. That's because our expect function doesn't return what we want. Return expectation. Let's see now. Okay, and here we are. So we are running the test in a new format. Of course, this test is not correct because we are expecting 2 to equal 1 and it's success. But that's because our test doesn't throw any exception now. Because we are not throwing any exception, then our test runner assumes that this test is correct. We're basically saying, okay, if there are no exception, then it's correct and let's pass it. So now we're going to make sure that if the results are not correct, we are actually failing the test. So our toEqual function needs to actually determine whether two values are equal or not. For now, under the hood, we can use the word assert, but we will get rid of it in a moment. Let's see if that will work. Nice. So the test num failure actually returns a failure and test num success returns success. But I don't want to use the assert keyword here. I want to just build something that will be on our own. So for now, we will replace it with if else. Okay, so we'll build our own error here. We'll have a class called failed expectation error, and then we'll pass some more detailed message to that error class. So let's build it. We can do it as a child of a runtime error, and we will have a message here. So the init let's provide something more interesting than just expectation failed. Okay, but now we probably broke our runner. Let's see what's happening here. Okay, we have an expectation that we raised, but we never caught it. So our runner doesn't deal with the failed expectation error. Now let's change that. In our runner, we have this exception here, assertion error. Now, what we could do here is we could just replace it with the failed expectation. But that has a problem. The problem is that then our test will not work with the assert keyword anymore. This introduces a problem. If someone wants to use our runner but doesn't want to use our assertion library, it makes it impossible. We are tying the runner and assertion library together. But we can support both the assert keyword and our expect library without making a much of a mess. So let's try that. Instead of putting failed expectation error here, we'll just copy this and we will put it here. Now I don't have this class, so I need to import it. And now that should work. But here, I don't want to put this hard-coded message. I want to put the message that we are getting from the error. So we can pass it as e, and we can say e.message. Let's see if that works. All right, nice. So we are saying expected to equal 1, but we're not saying whether it's a failure or success. We're just passing it as a message. So let's change it so that we still see the running test, blah, 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 success or failure, and then we will pass this message. Okay, now that should be a nice improvement. Perfect. So we're seeing running test and failure expected to equal 1. Right, let's see if we can run it for the whole directory. And the name expect is not defined, which means that our bool test is not importing something. We can just copy this. Now it should work. And it does. And we have 2 failures, we have 2 successes. And if we run it for the tests directory that uses the assert keyword, it still works. So now our runner supports 2 types of assertions. It supports this assert keyword from Python, and it supports our own library. Now it's time to add a new function, toNotEqual. So let's add a new method here. Okay, and we also want to check that it can fail. Okay, so now this bool test should have 2 succeeding tests and 2 failing tests. And now let's add support to that, to our expectation library. We have the toEqual function, and now we'll have notToEqual. Can basically copy all these and replace it with this operator, and that's it. We have here test not equal failure, failure expected true to equal true. Okay, expected true to equal, that's a problem. Expected true not to equal. And we have it here, nice. Expected true not to equal true. Okay, but now we have a bit of a code duplication here. The difference here is only the operator, and the difference is the text here. Let's figure out how to deduplicate this code and to make it possible to add new methods that will not have to raise the expectation, and that will just add an operator that we want to do. Okay, let's create a new method here. We'll call it _assert. It will accept the assertion and a message. And we will say if not assertion, then raise failed expectation error, and we will say expected. Here we'll add message. And here we will add a comparison, but we need to pass this comparison there. Okay. And now what we can do is here we could just do self.assert, and we'll say self. Now we need to pass the comparison and not to equal. Now we can do the same here. Now we can just say equals. Now we can say toEqual. And then all these should be unnecessary. Let's see if that actually works. And it does, that's nice. But to be fair, I'm not a big fan of how it looks. So okay, it's already a bit of an improvement, but we're still passing the comparison here, and we are passing the self value, it's not comparison, and we are passing a message. It's kind of annoying. why do we need to pass the self value? Like, we already have the self value here, right? So since we are passing the comparison, we don't need to pass anything that relates to self value. Okay, so what we'll do instead here is we'll pass comparison, we'll pass operator, and then a message. And then we will say, if not operator, self value and comparison. So basically we will pass an operator function that will determine whether the assertion is true or not. Now the question is how to pass an operator. So of course we can remove these, and then we need to have an operator. But what is an operator? How to pass something like equals to as a function? For that we will use a built-in module called operator that has this thing. So here we'll pass operator.eq, and here we can get rid of this part, and we can pass operator dot not equal is not. That should be enough. Let's see if that actually works as an opposite of the eq. Here we cannot pass this as the name operator anymore because we don't want to use the name of the module and the name of the variable. We don't want it to conflict, so we'll just call it op. And here we can say op self value comparison. Let's run it and see what happens. All right, we have the test failure, test not equal failure, success. So everything works. So actually the is not works properly and the EQ function works properly. So let's analyze what is happening here. We are getting three parameters. The first is called comparison, and this is any value. So it can be a number, it can be a string, whatever. This is a value against which we are comparing the value that we got in the expect function here. The second thing is operator, and this is a function that takes value and it takes the comparison, and this operator will return true or false, and if it returns false it will raise the failed expectation error. That will be a string saying expected, the value, and then we have a message. So the message is a string like notToEqual. So all of that works, but it is easy to say, oh yeah, for equal and not equal, that works very well. But what if I want to say, I want to check whether an array contains a center element? Let's try this out. First, let's add a test here, spec array test. Let's see what happens if we run this now. Of course, it has no attribute toInclude. So let's add this. We'll call this element, and now we need to call the assert. So we'll call self.assert. We'll say comparison, so we'll pass the element here, and we will pass some kind of an operator, and we will pass toInclude. Now what will be the operator here? Let's check if the operator module actually has something like that. Okay, we have a documentation, standard operators as functions, we have less than, oh okay, we have the containment test. It's called contains. Let's see if that will work. Nice, test succeeded. So okay, so we use the operator here again. Let's think about something that doesn't have an operator. So let's say we will write notToInclude. Now we cannot use the operator contains or doesn't contain because it doesn't exist. So we will build our own function that will act as an operator here. Okay, so we'll add our own function, def notInclude. It will accept a list and it will accept an element. And then it will say element not in list. And now we are passing this function, and now if we call the array test, okay, we need to add a new test first. Test exclusion. I will say not to include. Let's see now. All right, we say expected 1, 2, 3 not to include 2, but it includes 2. So now say fail, and let's test a successful case. And number 5. And test exclusion success succeeded. So you see, now we can add not only the operators that are already defined in some module, but we can just write our own functions and we can pass it as the operator here. Before we wrap up this video, I want to do one more thing. Our reporting currently doesn't look great. It basically says tests failed, but I don't know how many tests failed and how many tests succeeded. So let's add it to our runner, and then I'll show you what we will build in the part number 3. So here we have a variable that says whether we have a success or not success. But instead of saying success or not, we will now count the successful tests and failed tests. So we'll just do tests, self successes, self failures. We'll start with 0, 0. And here we'll do, okay, if this works, then we will increase it. And here we'll do the same for failures. And now when we print the outcome, we'll say if self failures is 0, then we'll say test succeeded. But also I want to print the number of errors. So okay, let's print total number of tests. And now I want to say tests failed, and I want to say how many failures there were. Oh, we can actually say it here. Self failures, tests failed. Let's see how that will look like. Let's put the whole specs directory here. I will say total number of tests 9 and 4 tests failed. Okay, that looks quite nice. There is one more thing that I want to change here. I will add an empty line before the report. Okay, now we see that the number of tests, it's number of tests, not test. Now let's separate it even more. So let's say we'll print, okay, something like this to separate the test from the runner. And okay, that looks reasonable. So for every test, we are saying, okay, the test failed or succeeded, and we have a number of testing failed here. But you know what? When we have the failure, let's mark it already as red so that it's easy here to distinguish the failure from success. So we will just use the colors.red. Oh, nice. So now each failing test shows red color, so it's very easy to understand what exactly failed there. And finally, the running test text doesn't look good anymore. I don't like it. Let's just start with the test name instead. That's all that I wanted for now. Right, folks, we are at 97 lines of code right now. So our 100 lines of code testing framework is complete. But in the third part, we will add some more functionality. We'll cross that 100 lines, but we will add something interesting. We will add a number of methods like before or before all that will be running before each test or before all of the tests. And we will wrap the tests in a class so that we can share some state between them. So at the end of that, we will be able, for example, to establish a database connection that will be reused across all the tests, or we will be able to clean something before every single test. And that's all for today, folks. I hope that you enjoyed it. Make sure to like this video, make sure to subscribe to the channel and to leave some comment, and I will see you next week. Take care, folks.